So yesterday we did those first four as a class. Supposed to finish up these other ones. Let's go ahead and just kind of go through them. Make sure we're good. So g of x. Our g of x equation, since we have g here, we're using the g of x. I'm going to rewrite the g of x equation just next to it. So we have it. G of x is equal to negative 2 and then x plus 4. Now, helping you guys out, it was really nice to see some of you actually put the parentheses there because that helps you out. If it's in parentheses, what you have here should be the exact same thing you have over here. Remember, this is just a name, right? So that's the name. We don't really worry much about that. But this, since this says g of negative x, this x can't be x anymore. It no longer says g of x, it says g of negative x. A negative x replaces that. Parentheses replace parentheses. Okay, so our solution ends up being negative 2 times negative x, or positive 2x plus 4. That's what it equals. And what's this function's name? G of negative x. It's not g of x anymore, it's g of negative x. G of x is this. This name is g of negative x. Don't do any math on this side. That's just its name. All right? Raise your hand if you have questions on these, okay? If not, I'm just going to keep going. Okay? This next one here, the g of x we have, so we're going to use g of x equals negative 2 x plus 4 again. All right? Notice this says x, and, oops, I put the parentheses in the wrong spot, I'm sorry. This says x, and that says x. So we're still with g of x. This just says we're putting the whole g of x function right here. So this time we're replacing this g of x with that. Okay, so we have this g of x and that g of x are the same thing, so we can plug that in right there. So we have 1/2 times negative 2x plus 4. Distribute, we get negative x plus 2. Okay? What's that function's name? It's not g of x. Yeah, this is 1/2 g of x. 1/2 g of x equals that. All right, any questions there? That's it. Negative x plus 2. What's 1/2 of negative 2 is negative 1. Audrey, question? Yeah, because it says g of x. Yeah. All right, moving on. Next one, g of x plus 5. So, once again, g of x is equal to negative 2x plus 4. And I'm replacing g of x with g of x. Okay, so this replaces that. It's plugged in right there. So we have negative 2x plus 4, all plus 5. Okay. And that gives me negative 2x plus 9. So g of x plus 5 equals negative 2x plus 9. Remember, do I do any math on this side? No. This is just its name. Okay. Okay, moving on. So we're still dealing with g. So g of x is equal to negative 2 x plus 4. Notice this time this says x, this says x minus 5. So parentheses replace parentheses. That goes in right there now. So I have g. Thank you. So this piece goes in for that. Parentheses replace parentheses. So g of x minus 5 is going to be equal to negative 2 times x minus 5, all plus 4. Remember, this is a name here, so we'll kind of ignore it. We get negative 2x. We get positive 10. And then we just have the plus 4 at the end. We don't distribute that. So that's equal to negative 2x plus 14. That's g of x plus 5. Okay, questions? Yeah. Oh, I'm sorry. This should say g of x minus 5. Thank you, Jack. Okay, the next one, we're dealing with f now, so remember that's 3x minus 2. So f of x equals 3 times x minus 2, like so. And then, remember we're finding 1/2 x, so parenthesis replaces parenthesis. So f of 1/2 x is equal to 3 times 1/2 x minus 2. Or 3/2 or 1.5x, I saw a lot of you had, minus 2. So that's f of 1/2 x. All right. How many are doing pretty decent on it? Okay. Next one, number 28, we're going g of x. So once again, we're using our negative 2x plus 4. G of x equals negative 2x plus 4. Notice our parentheses are both the same, so this g of x is this. I don't know why I have a parenthesis right there. Add an extra piece there. Okay. So I'm going to replace g of x with that function, negative 3 times negative 2x plus 4, which gives me 6x minus 12. So negative 3 times g of x is equal to that. So again, do we do math over here? No, that's just its name, right? Leave that alone. Okay, we are now to the h of x ones. H of x is equal to 5. So when I'm solving this one, h of x equals 5, is there a place for an input? There's no x. Okay? So that's going to come into play here in a while. Now, right now, this just says h of x, and that says h of x. So those are the exact same thing. So I can plug the 5 in for the h of x. That just gives me 5 minus 4, which is 1. So h of x minus 4 equals 1. That is the solution there. Remember what we're graphing here. Like if I was to draw a picture of this, it's the same as y equals 5. Y equals 5 is like right here. It's that line. So this says I'm taking my function and I'm shifting it down 4 units. So it just moves down 4, it moves to 1, which is what this is saying now. Yeah. Are you, hold on, ask that again. The 5? Yeah, I put that in for h of x because this says the exact same thing as this. Yeah. If they say the exact same thing, just like on number 28, this says g of x and this says g of x. So I replace it with its other name. Okay. This right here, though, this doesn't say h of x, right? It says h of x plus 6. So we know h of x equals 5. We don't know what h of x plus 6 is. And notice over here, there's no x to replace. Like when we were doing, say, the problem right above it with the f of x, this said f of 1/2 x, but I could replace this x with the 1/2 x. I don't have a place over here to put this into. Okay? Remember what this is saying. Remember, is this a vertical or horizontal right here? This is horizontal. It's a horizontal translation, 6 units to the left. Now, if I take this line, which is what, so if we were to take that line, which is y equals 5 or h of x equals 5, and I move it 6 units to the left, is that line going to change? No, it's this exact same thing. It's the same line going through that point. So when you see this and there's no input, your answer is just the same thing. It's still 5. Nothing changes because there's nowhere to change an input value. Right? So, like on 31, h of x equals 5. My input over here, there's nowhere to input it, so h of 2x is still going to be 5. Okay, this one says you have 2 h of x's. Well, h of x is 5, so if I have 2 of these, what do I have? I have 2 times 5, which is 10. So h of, or 2h of x equals 10. The last one is f of x minus 3. I'm going to go ahead and take my f of x, which is 3 times x all minus 2. We're going to go ahead and plug this piece in for f of x. It's going to be 3x minus 2 all minus 3, which gives me 3x minus 5. So f of x minus 3 equals 3x minus 5. So again, do we have to do math with this piece? No. Oops, I'm sorry. With this piece, that's its name, right? Okay, so no math going there. It's just 3x minus 5. Okay, how many got over half of them correct? How many got all of them correct? How many missed only like 1 or 2? Well done. Okay. All right. So just a really, really quick review to make sure we're clear. All right. We've talked about vertical translations. Hey, pay attention, please. We've talked about vertical translations. So if I have a function f of x and I add something to the back, it's moving my function up or down. Up positive, down negative. Okay, we talked about horizontal translations. Remember, that happens, horizontal happens on the inside. Vertical's on the outside. So if I'm subtracting something in there, or adding something, it's moving it left and right. Now remember, it's backwards on the inside. So left actually is our plus, and right is our minus. Okay, so vertical affects my output. Horizontal affects my input. Okay, so just a real quick review. We did vertical, stretch, and compression. Okay, vertical happens on the outside of the parentheses. That's the A term. It affects the output because it happens on the outside, or the Y value. And this vertical stretch, if A is bigger than 0, or excuse me, greater than 1, then it's stretching. If it's between 0 and 1, then it's it's compressing, or we also call this compression, we call it a shrink. Okay, so our stretch is when A is greater than 1. Our shrink was when A was greater than 0, but less than 1. And really we're talking about the absolute value of A. Now I'm going to add some symbols there, and some of you are going to go, whoa, hold on, what are we talking? That's messed up. Okay, that just means if we just consider the positive value for A, even if A is negative, just consider its positive value. We have not talked about the reflections, which we will here in a minute. We did talk about horizontal, stretch, and shrink. Remember, horizontal is inside. It affects the input. And the stretch is, once again, when A is, or the absolute value of A is greater than 1. And the shrink is when the absolute value of A is less than 0, but greater than 1. Okay, that we have covered in the last 2 days. I'm about to show you reflections, which are pretty darn easy. Okay? All right, so let's talk about a reflection in the x-axis. What I want you to do down here on this page, reflection in x-axis. If you want to add it to your other note page, you can, but I'm going to put it right here. You'll notice they have reflection in x, reflection in y on here. Well, reflection in x. I just want you to draw just a quick x-y axis like so. And I want you to put a point just anywhere in there, just anywhere in that quadrant. Just so that we're clear, when we reflect across the x-axis, or reflect in the x-axis, that means my point is it moving up or down, left or right. It's moving down. It's moving to here. So if I'm reflecting, I'm moving from here to there. Now, is that a horizontal or a vertical? It's moving vertically. Now, you know vertically means that am I inside or outside of the parentheses? Vertical happens outside. Okay? So this means I would have f of x, but I would have a negative on the outside. Anytime you see a negative out here, you can have a number after it, like you could have -5, but if you see a negative out here like that, that means you've reflected in the y-axis or the x-axis. It's vertically. Okay, and that's what this is saying here. It affects your y value. Now, if I'm going reflection, oops, got to spell reflection right there. Reflection in the y-axis. Taking this, I'm going to put my point here again, and I always visualize this when I'm doing these. Okay, if I'm reflecting in the y's here, I'm moving horizontally, right? It's reflecting that way. That means it's changing. Is horizontal inside or outside? It's inside. So now I have f of -x. So these negative signs, when you're multiplying x by -1, or you're multiplying f of x by -1, or a negative sign, that's a reflection. This affects your input. This affects your output. Just remember, input goes horizontal, output goes vertical. Input is x, so it's changing how you'd move along your x-axis. Output is y, so it's changing how you'd move along the y-axis. I know this is reflecting in the x, but this point is moving from here on y to here on y. I know this is the y-axis, but this point is moving from here on x to here on x. So it's a horizontal movement, whereas this is a vertical movement. Okay? Any questions? Okay, here we go. Let's turn the page. Let's see how well we understand input-output here. Suppose 6,1 is a point on the graph f of x. If you want, just come on up here and let's plot 6,1. Everyone plot 6,1. Just draw a quick graph, grid, plot 6,1. 1, 2, 3, 4, 5, and 6, and 1. It's right there, right? Order pair 6,1. Okay, 6,1 is a plot on a graph of y equals f of x. In other words, it's a point on some line. What line? We have no idea. It could be any line. It just depends what we say f of x is. If we said f of x is equal to 3x plus 1, we could graph 3x plus 1, and maybe that point's on it. I don't think that point's on 3x plus 1, but we don't know. It's just a point. For each of the following, name a point on the graph, then name its transformation. So what we're doing here is we're looking at this, and we're saying, okay, I'm taking 6,1, that point. Remember, this is x, this is y. X is called our input. Y is called our output. I am taking that point, and I am changing. It's inside. Which am I changing, input or output? I'm changing everyone. It's on the inside, it's changing the input. It's changing our x value. It's doing a horizontal movement, right? Remember, inside is horizontal. It's changing the x. So when you say, okay, inside's horizontal, sketch that. Okay, it's changing the x-axis. All right? So this is input. It's taking all my x's and it's doing what to them?
Moving them.
Yeah. So what's it saying we're doing to x here?
Moving it 3 units.
No. Not adding to it. We're not subtracting either. What's it say we're doing right here? Multiply. We're taking our x and multiplying it by 3. So what is this now? Yeah, so it's 3 times 6, which is 18. Did we change our output? No. So our y, that almost looks like a 7. Okay? Our y is still 1. Input changed. So this is is it horizontal or vertical? Does x change horizontally or vertically? So x is a vertical movement? Yeah, it's horizontal. Okay, it's a horizontal, and I'm going to just put H for horizontal. Is this a translation or a stretch shrink? Okay, let's summarize some things again. All right. Hey, if it's inside, it's horizontal. Okay, inside is x. So if you think of it that way, it's our x. If it's outside, it is vertical. And vertical is our y. So the first thing you need to ask yourself, is it inside or outside? So let me give you a checklist. We determined this one was inside. That's the first thing we ask ourselves. Second thing we ask ourselves, once we determine that, are you adding or subtracting? Or are you multiplying? I guess dividing is the same thing as multiplying. Are you adding, subtracting, or multiplying? What are we doing? We're multiplying. Remember, adding and subtracting is called a translation. It is a slide. Okay, that's kind of the slang term. We slide our graph. Not slip our graph. We slide our graph. If it's multiplying, it's either a stretch. Tell your neighbor when it's a stretch. It's not when it's just multiplying. Blake's the only one I heard. It's either a stretch or a shrink. When is a stretch? When is a shrink? Look back to your notes. Okay, volunteer, when's this a stretch? It's a stretch when you are multiplying by a number, when a is greater than 1. Okay? It's a shrink when a is between 0 and 1. Okay? So we write it like that, right? That just means a is between 0 and 1. All right, so let's go back to this. This is a horizontal. Is it a stretch, shrink, or slide? It is a stretch. Now we say by a factor of, and I get sick of writing out the words by a factor of. So I use, and this packet uses, B-A-F-O. BAFO. By a factor of. All right, if your neighbor didn't understand what that means, tell them later. Okay. By a factor of, horizontal stretch by a factor of 3. Okay, we're using the same point again. 6-1, we start with 6-1. Right here, tell your neighbor, is it horizontal or vertical? Okay, how many say horizontal? How many say vertical? Is it inside or outside? How many say inside? How many say outside? How many say inside? How many say outside? Okay, is it horizontal or vertical? Is it inside or outside? Inside. Everyone says it's inside, but half of you say it's vertical and half of you say it's horizontal. If it's inside, it is horizontal. So is it horizontal or vertical? This is horizontal. Okay? So it's a horizontal. Is it a stretch, shrink, or slide? Tell your neighbor. So you're adding or subtracting, or are you multiplying? You're adding, so it is a slide, which we call a translation. Okay, I want you to use the math term there. Horizontal translation. Which way are we going, left or right? Remember, when we're doing a translation, if we're going horizontally, maybe make a note to yourself. Horizontal translation, this is plus, this is minus. Vertical translation, this is plus, it's normal with vertical. So which way are we going? We're going to the left because it's plus 2. We're going left 2. So, if I am doing a horizontal, and that horizontal affects which value? The input or output, or the x or y? The input x. What are we doing to our x's? We're adding 2. Okay? So, be careful here. Go ahead and tell your neighbor what the value is right here and right here. Say 8-1. How many say 4-1? All right. I'll tell you it's 1. How many put 1 there? Good job. How many say 8-1? How many say 4-1? The answer is 4-1. Remember, everything is backwards. If it says you're adding 2, you're actually subtracting from that value. It's backwards. Which, by the way, that should tell you guys something up here. What did we screw up on? We messed up on this first one. Lucas. Yeah, we multiplied and we were supposed to go backwards and we should have divided. This should have been what? 2. Yeah. And it's not actually a stretch, it's a... This is a shrink. Okay, so remember, it's backwards. Those are going to be the mistakes that we make, all right? So this is a horizontal shrink. Can you shrink by 3? You can't shrink by a number bigger than 1. What is it, Kristen? Yeah, this is actually the reciprocal of 3. The reciprocal of 3 is 1/3. Hey, be careful there. Okay, I want you to go to the next problem. I want you to go to the next problem here that is actually a horizontal movement. Okay, so tell your neighbor which next problem number is a horizontal movement. Okay, which one is it? Number 6 I hear, and number 5 I hear. Why number 5? Yeah, so it's number 5. All right, tell your neighbor what's going to happen with that one. Okay, what's the negative tell us? Remember, it's the last thing we added today. It's called a... Yeah, it's a reflection. Reflection. If it's f of negative x...
It's reflection in the y-axis.
Reflection in the y-axis. That is a horizontal reflection in the y-axis. Now remember, if it's negative f of x, that is a... Yeah, it's a vertical reflection in the x-axis. Okay? So, on this problem here, we have, this one is a horizontal. Now, usually you wouldn't write horizontal or vertical, you just write reflection. But I'm trying to stick with our horizontal and vertical theme. Okay? Luke?
I'm confused. How do you tell whether it's like a stretch, shrink, slide?
Can we do that after we finish this problem? Okay. So let's go to number 5. Is this reflecting in the x or y? Number 5. This is a reflection in the y-axis. Okay? Is it changing our input or output value? Input. So which one, x or y? It's changing our x. It's taking the opposite of x. What's the opposite of 6? Negative 6. All right. So Luke, maybe we'll hit that. I think we're going to hit that right down here on number 8. Okay. You're asking about when do you know it's stretch or shrink? Okay. We're going to hit it in number 8. Okay. Look at number 6. Tell your neighbor what's happening there. Okay, vertical or horizontal? How many say vertical? How many say horizontal? Well done. Horizontal. Horizontal, how many say stretch? How many say shrink? How many say translation? How many say stretch? How many say shrink? How many say translation? Okay, let's look back up here. What are we doing? Are we add, subtracting, or multiplying?
We are subtracting.
Subtracting. How many say stretch? How many say shrink? How many say translation? It is a translation, yes? So we're subtracting. So we are subtracting. It's a horizontal translation, which is the same thing as a slide. Horizontal translation. Which way? Left or right?
Right.
Good job. Yeah, right. 7. Okay? So if I am moving this point right 7, think about it. You're on the x-axis. You're at 6 right now. And I'm going to the right 7. Where am I going to end up? Yeah, I have to add 7 to it. We're going to be at 13. Remember, it's backwards there. So if you can figure out the description, then you can think, oh, hey, my point's right here. I'm going to move it right 7. It's right here now, which is 13. Okay, which one's the next horizontal? Yeah, number 8. Okay, number 8, we've already determined it's horizontal. Tell your neighbor, is it a stretch, shrink, or translation? Okay, how many say stretch? How many say shrink? How many say translation? Okay, so everyone agrees it's a stretch or a shrink, yes? Okay, very good. So now let's figure it out. Stretch, shrink, remember everything is backwards on the inside. So this 1/2 is actually the reciprocal, which is 2. Okay? So maybe our notes might be a little off if we're dealing with horizontal, right? Because when we're dealing with our horizontal, maybe you need to change your notes. Okay, this would be like for vertical here. Okay, for horizontal, it's kind of backwards, right? So it's a stretch. It's a stretch when you see a value that's less than 1. I hesitate to write that because really you're not writing that value down. So like this value says 1/2, but this is a stretch. So Luke, this was your question. You see 1/2 in here. Remember, everything's counterintuitive inside. You have to flip that. So this is actually a horizontal stretch by a factor of 2. You have to remember here, it's backwards. You got to flip that to figure out if you're stretching or shrinking. Okay? And then if I am stretching this by a factor of 2, that means I'm taking my point that was at 6,1 right here, and I am stretching it away from the y-axis. So it's currently 6 units away. If I'm doubling that, where am I going to be? I'm going to be now at 12. So that coordinate is now 12,1. Okay, the horizontal stuff is all the messed up stuff. Vertical stuff's a lot easier. So everything else is vertical here. You have 4 problems, 3, 4, 7, and 9. I want you to do those with your groupies, please.
So wait, the rest of them are vertical?
I think so. They're all on the outside, yeah. Hey, let's see how we did. This one right here, we've determined they're all vertical because they all happen on the outside, right? So everything's on the outside. And remember, everything on the outside is very straightforward. There's no backwards or anything like that. So, Sam, what do you got?
We got translation.
Good. Vertical translation. Which way? So vertically, we can only go up or down, right?
Yeah.
What do you think? No, it can't go left on vertical. It has to be up or down. Yeah. Up 5, yes. All right. So it's plus. You guys remember, use this stuff up here. I saw some of you are using it when you're going through. If you haven't written that down, hope you go back tonight and write it down if you still need it. Vertical translation up 5. That means I am changing my X or Y. So we start at 6, 1. We're changing Y. We're changing it 5 units greater, which is 6. So think of it graphically. I'm moving now from 1 up to 6. I'm going up 5. Brings me up to 6 there. Okay. 6, 6, yeah. All right, so number 4, vertical or horizontal? Vertical. Stretch or shrink or translation? This is a shrink, yes. We are multiplying, so it's either a stretch or shrink, and it's less than 1, so it's a shrink. BAFO, or by a factor of 1/2. So we're changing our Y value from 1 to, you got to shrink it. So remember, you were at 1 on the Y-axis. You were shrinking towards the X-axis. So you were 1 unit away. Oops, excuse me, that's 6. Okay, you're 1 unit away. Now you're going to be a 1/2 unit away. You're now moving it to there. You're shrinking this distance halfway. This 1/2. All right, number 4. Number 7, vertical is a stretch or shrink. Stretch. BAFO, 4. Okay, so our value that was at 6, 1, that Y is going to become 6, 4. We are multiplying it by 4. Yep, you multiply the 1 by 4. And the last one, it's a negative out here. Good. The negative means reflection. In the, it's a vertical, so we were here. We're going vertically, so it goes this way. So it goes over X. Yeah. So always draw a quick sketch if you need to. So we were at 6, 1. We are taking the opposite of our Y, which is now negative 1. Okay, how many think you got it? No? You got some questions? You just going with no? Okay. All right. Moving on, next page. Okay, these next pages all the way until the very last page. So this one, turn the page, you look at the next page, and the next page, and the next page, and the next page. There's only like two or three problems per page. Okay? The back one you're not doing today. The back one we're doing tomorrow, but this is what you're doing here. You are taking your graph. You are looking at this function. Notice this is a weird looking graph. I get most of you haven't ever graphed anything like that. But this says something. Tell your neighbor what that says. Do not just read y equals f of x plus 2. I know what that says. Tell mathematically what it means. Okay. So, can someone tell me what this means? Sam. Y plus 2. It means all my y values, I am doing a vertical translation up 2. It means all of my y values are moving up 2. So if I find perfect points like this one, notice it hits the grid. I'm moving it up 2. Just slides right up. Okay? I am finding another perfect point. Everyone find another perfect point. Good. 0. Where's that one go to? 2. I'm finding another perfect point. Negative 2. Let's bring it up 2. Good. And bring it up 2. So all of these points have slid or translated up 2. You now trace your new graph. That's how that changes that function. Okay? What you're doing right now is we'll just keep cranking through as many of these as we can right now. So try this one. Okay? Letter B. Hey, well done. I see some of you got it. What's this mean? Yeah. It is a reflection. It's a reflection in which one? It's a vertical reflection in the x-axis. Well done. That means if it's a vertical, you're changing which values, x or y? That's your y. Vertical is this way. It's your y. So this point that was here reflects downward to, it reflects over this. Here's your mirror. It goes down to negative 3. Well, what happens if your point's actually on the mirror? It stays there. Well, this point that was at negative or at 2 goes to negative 2. Well, the 4 is on the mirror, right? So it stays there. So if I'm connecting my points, it's kind of tricky looking, but it should be a mirror image. I kind of messed up on my curve here. I don't want you to get too picky about your curve, but I mean it should be a mirror image of what you had up above. Yeah. So this piece that was down here is now up here. This piece that was up here is now down here. This piece that was up here is now down here. Yeah. Yeah, do your best. Okay, right now I'm just more concerned that you know what's happening. Okay, next page. Woohoo! All right, number 2. Well, let's look at it because Jacob doesn't understand, he says. It says the diagram shows part of a curve with the equation y equals f of x. In other words, it gives us a function. That's what that says. The name of this function is f of x. The coordinates of the maximum point. The maximum is this. A maximum is the highest, right? The biggest. This is the highest point on our graph. Right, Brady? Brady looks pumped about it. Okay. That's our maximum. Write down the coordinates of the maximum point. So in other words, change this point when this happens. Write my new coordinates. So how does the ordered pair 2, 3 change when I do this to it? How does the ordered pair 2, 3 change when I do this to it? Okay? It's like what you just did on the previous page. Go ahead and work on it. Okay, kind of running out of time. What's this? Is it a horizontal or vertical? Horizontal. Slide, stretch, or shrink? Slide or translation. Which way? Right. Right, 2. So that means x is changing. It's going from 2, and it's going right 2, so it's going to where? To 4. So it's now at 4, 3. How many got it? Well done. All right. Hey, this one right here, vertical or horizontal? Vertical, stretch or shrink? It's a stretch. Bafo, 2. So that's changing to what? 6. All right. Hey, you got to finish up through the last page tonight.